Hello everyone, this is Dick Mish with Fizz Dispense Optimization Group. Today's presentation is how to use CO2 nitrogen blend charts. If you need further information, you can always reach us at www.fizzdog.com or 1-800-253-6610. Hope you enjoy. This is our basic blend chart. You will see on the left-hand side CO2 content volumes per volume, and that ranges from 1.0 to 3.0. At 1.2, you have Guinness Stout. That is also any nitrogenated beers, Boddingtons, Murphy's Irish Stout, and so on. At about 2.3 volumes, you have typical micro ale, which are imports, and also microbreweries beers typically are in that range. And then the mass market beers domestically are somewhere between 2.6 and 2.8. We use kind of 2.7 as a good ballpark. Along the bottom of the chart, from 0 to 60, is the applied pressure to the keg in PSIG from 0 to 60. And the reason why it maxed out at 60 is beer systems typically have relief valves that max out at 60 psi. You can't put any more applied pressure on a keg than that. Also, you'll notice all the different colored lines that kind of come out from the lower left-hand side. Those are CO2 percentages. So from 100 in the upper left to, say, 20% down in the lower right. And those are the percentages of CO2 in the blend gas, depending on, again, the type of beer, its CO2 level, the applied pressure, and the temperature, which is, for this chart, 38 degrees. We are able to do customized charts based upon any temperature. Just for this informational purposes, we're going to use 38 degrees as the baseline, and that is liquid temperature in the cooler, so actually what the beer is seeing in the way of temperature. So now we're going to give you a couple of examples. The first example we're going to do is Guinness Stout, or any nitrogenated beer with 1.2 volumes at 38 degrees Fahrenheit. And applied pressure is 32 psig. So if you take the 1.2 black line from the left and go towards the right and intersect with where 32 psi is, you will hit 25% CO2. And you can tell that because of where it falls between the 30 and the 20 psi. So that range is 25% CO2, 75% nitrogen for Guinness Stout at 32 psig at 38 degrees. The next example is going to continue to be Guinness Stout, but I just wanted to show people that 25-75 might not always be the issue, depending on what the applied pressure is. So at 38 degrees, Guinness Stout or any nitrogenated beer, but at 44 psi, will give you 20% CO2, 80% nitrogen. That's where that light blue line intersects. That gives you the 20% CO2. So now we're going to move on to microbreweries and imported beers, typically 2.3 volumes. And again, we're going to stay at 38 degrees Fahrenheit. We're going to put the applied pressure at, say, 23 psi, so somewhere between 22 and 24 psig. If you do the intersection of that typical micro ale at 2.3 volume and 23 psi, you'll come up with that pink line there that says 60%. So 60% CO2, 40% nitrogen would be applied to that beer, just because that's where that pink line intersects with those two on that chart. And the last but not least is we're going to use a 2.7 volume beer. We're going to call that a mass market beer, a domestic mass brewed beer at 2.7 volumes, and again at 38 degrees Fahrenheit. And we're going to do the same 23 psig. So your intersection point for 2.7 volumes at 23 psig at 38 degrees is 70% CO2. And I hope that's easy enough to understand. So these charts can be used basically with that same idea in mind, which is What's the CO2 volume, or what kind of beer do I have? That's the left-hand side. What pressure is applied to the keg? Just go to the keg cooler and figure that out, and figure out the liquid temperature, and then you can determine the gas blend. Thank you very much. Have a great one.